want to welcome everybody to our roundtable discussion today. I appreciate you joining. Hopefully we can have some good conversation and information for everybody. My name is Nick May with RENVU. Just go ahead and introduce everybody real quick and let them say a little bit about their companies. Joining us also from RENVU is Erez and Kyle. From FIMER, we've got Jim and Juan. From APsmart, we've got Yi, and from Humless, we've got Eric. So I'll go ahead and kick it over to Juan at FIMER first, just to talk a little bit about FIMER, give a little background, and then we'll jump over to Yi and Eric, and then we'll kick everything off.
Thanks, Nick. Hey, everyone. My name is Juan Afanador. I am the regional sales manager for FIMER, located in Austin, Texas, focusing more on the southeast and central part of the country. If you guys haven't heard of FIMER before, FIMER is the fourth largest inverter manufacturer based out of Italy. We've been in business since World War II, always as an electron specialist, focusing on welding machines, and then later in the 80s, getting into the inverter technology, EV space, and also batteries. But we're really making a name now in the United States after acquiring the solar portion of ABB and thus Power One. So maintaining the manufacturing in Italy, the good inverter offerings from residential and 3 kilowatts all the way up to utility and 350 kilowatts of string and also 5 megawatt centrals, as well as an upcoming EV charger infrastructure line and storage products. So that's FIMER in a nutshell, and happy to support you guys with any sort of question you guys might have.
Excellent. Thank you, Juan. We'll go ahead and kick it over to Yi if you want to do a little interview or introduction for APsmart.
Sure. Yeah, thank you. My name is Yi Kang. Just call me Yi. When come from APsmart, actually, APsmart is under the AP system, which used to be a microinverter AC side business. Right now, we are extending into the DC side business. The first product we push out is a rapid shutdown solution. So you can see on the mark there, APsmart first product, the RSD-S-PLC, is a one-on-one rapid shutdown solution for each PV module for fulfill AEC 2020-2017 standard. Right now, we also have a RSD-S, which is a 2-on-1 device. So we are happy to help everybody, guys, help the industry to move forward. Thank you.
And then last but certainly not least, Eric over at Humless.
Well, thanks for letting me join in on this webinar. I appreciate the invitation. I'm Eric Lobdell. I'm with Humless Energy Storage Solutions. We build both energy storage solutions that can be grid tied or off grid, that AC and DC couple simultaneously. But we also build as well a 5 kilowatt hour energy cell. So it's a very popular UL listed lithium iron phosphate cell that can be a drop-in replacement for lead acid, but is also used in our energy storage systems. Very exciting product. It's been just in today's world, a hot ticket item for us, and we're excited to be offering it to the American market.
Excellent. Cool. Well, yeah, now that we're done with introductions, I think we'll go ahead and kick off our first questions. For anybody who's listening in, if you do have questions, please feel free to use the Q&A section of Zoom to ask those, and we'll either get to those at the end, or if they're particularly relevant to a topic of discussion that we're having, we'll bring them up at that time. So taking a look at our first question for everybody, it's probably the biggest question on everybody's mind right now is the topic of supply chain and logistics. So we wanted to get everybody's feel for what the situation in the current supply chain market looks like and how it's affecting your particular companies in the overall market. Yeah, so anybody who wants to jump in first and give their take on it.
Sure. Go for it, yeah.
Yeah, actually, we've been hit pretty badly. So far, I know for the last quarter, at least we have been delayed 2 shipments. So both shipments at least already on port. So they just delay the process into customer. And a lot of guys chasing me for a couple of months already and say, where is the product? So I say, I know where, but I cannot get for you, actually, to be honest. So yeah, and since a couple of weeks ago, especially from the last week, I see there is a progress. I think the government did some work to help to solve this issue, and I saw our shipment starting from our warehouse right now, which means that at least one of the shipment already inside of U.S. customs. So is in the progress. I think pretty soon we can see that this problem will be solved. But right now, yeah, we've been delayed pretty big.
I actually agree with that. We're all hoping it gets better, but also I think some transparency is important too. And I'm very open with our customers that we are 6 to 8 weeks in build and back order, and there's certain components that are harder to source than others. But hopefully, and we're knocking on wood over here, that it will be getting a little better and very soon.
Yeah, so maybe we're a little bit of the outliers there. We haven't suffered a little bit through the unpredictabilities of shipping in today's day and age after COVID. But because our products are coming from the Eastern ports, from Italy, we haven't been held up that much. And our inventory has been holding up well to our forecast so that we can always be shipping readily. Regardless to say, though, it's important to kind of hold up that transparency with the customer, set the expectations straight, and say, hey, maybe there's a little bit of longer lead times than necessary, but it really hasn't been a major effect to our business, except a little bit when we talk about the service side of the industry, right? So when we're looking at specific small components like microchips, and we talk about shortages, that's a little bit of a different conversation than the situation at the ports.
And how does it affect the pricing in the market? Do you see the spike in the supply chain and logistics affecting the prices that you're offering?
Yeah, pretty much.
How much? It's single percent or 10% and more?
I would say that's hard to answer. I would say it is in the single percents in the 5 to 10, but it's multiple components. Shipping costs have definitely grown quite a bit. The cost of the chemical cell is up a little bit, but the cost to get the chemical cell to me to manufacture Henley Nice, it's gone up as well. So it's a very difficult time to answer that question, but it is single digits for now, but it's hard to answer that.
Okay.
Yeah, actually, continue from this topic is another thing. Frequently power off from mainland China is also probably will impact on the manufacturing side. I know Italy, we had the impact at a certain level, but I believe the government tried their best to try to solve this issue to help the manufacturer to continually produce, but the shortage of the energy is working right now. So let's see what's gonna happen.
Let's shift from this question to a little bit more about the market, the U.S. market. We know that it is a little different than Europe or Australia and other countries. How do you see, the ones of you that are working globally, how do you see the difference in the U.S.? Is it for good or for bad? And what would you like to see changing here? And let's start with FIMER.
Yeah, it's tough to say whether something is good or bad, right? We can just kind of talk about the differences in the market. The electrical differences, of course, is that the U.S. has the 60 hertz, 120 volt grid. Different parts of the world have 50 hertz, 220, 240. And so that has a little bit of the different products that are used in different markets, right? But when we dive deeper into Europe versus the US, and we look at the specific cost of solar, the United States is by far the most expensive market for residential solar. It's the average cost is about $275 per watt, and that's without the tax credit. Meanwhile, if we look over the pond at the UK, average system cost is $1.50 per watt, and Australia is $1.33 per watt. So there's a lot that can be done to reduce those costs, and I think it's a little bit coming from the federal policy side of things, in which like the United States relies heavily on local policy incentives, and it's very piece by piece market approach than what the other countries are. This kind of speaks a little bit to FIMER's power, though, a little bit in Europe as well, though, because as there's a higher interest in people to have a lower cost of energy for their system, that's when FIMER can respond with their European product in Europe. So to speak a little bit about that, that's why our products are focused on just affordability and simplicity, right? We don't need to make it complicated with different types of loan structures for the full system, and that's how we can compete in Australia and Europe quite well.
Do you think the reason for this is more components in a system, or different components, more MLPE, for example, rather than string inverters in the US compared to Germany or UK?
Yeah, I think the number of components is definitely significant. The amount of installations that have MLPEs and different types of cables, different types of other components inside is significant. It's significantly more in the United States than other countries. But I think it goes beyond that. Also speak about the full package, right? The price of modules really affects it, really affects the whole price of wire, the price of soft labor. And so these are the other soft costs that without an overarching policy change saying, hey, this is how we're going to incentivize the full industry to take off, we'll just continue to have this rapid growth as a grassroots, localized, market by market approach, I think.
Okay. My next question is for Eric at Humless. Is there a shift? I mean, when the storage market started, we saw or heard only about Tesla Powerwall and later LG Chem. Do you see a shift that those players are losing market shares, and there is place for the other manufacturers to play a role?
Absolutely. That has been the big change. I kind of joke about a tidal wave. When solar started in America and it got so popular, it was a tidal shift, and it was PV solar, just glass on the roof. And then that shift changed as the American market learned that grid-tied solar needed a grid to function the way the consumer wanted it, and battery storage followed right in with that. And yes, Tesla is a name brand that everyone knows, and it's a well-branded product. But the shift has already happened. There's a lot of new players in the market already. We can speak to Generac coming in and purchasing the Pica system. So there is new players in the market. We did 6 megawatt hours in the last quarter of last year of energy storage in the American market, a little bit in the Caribbean, a little bit in Mexico, but mostly to the American market because of that shift in perception. Energy security has become a topic that people discuss, where that never happened 10, 15 years ago when the grid was so, let's just call it more stable, when the grid was far more stable. That perception is what's changing the requirements and the thoughts and the need for energy storage. So it's changed quite a bit, actually, and quickly.
Okay. About the regulations, and I wanted to ask you if there are any upcoming changes in the regulations, any C code or local adoption that could affect the market, and maybe we should bring it up so our customers and end users will know about it.
Yeah, there is one new thing come out is they see required on the module, the maximum voltage must be less than 80 volt. And the UL will be follow up as well. That's
okay.
Yeah.
And currently your solution is not yet ready for this, or it's?
We're already, yeah. So SoundSpec actually required all the module level running the shutdown solution must be less than 80 volt. So we follow standard. I think the only effect on some of the manufacturer which have a higher VOC level, something like some power. They used to have a high power or high voltage PV module that could be influenced.
Yeah. I mean, same issue with NEC code applies also for the energy storage market with requirement to install outdoors. How do you see this? Eric, do you think that eventually it will happen, or it doesn't make a lot of sense because in lower temperatures areas you cannot really install outdoors? Will there be solutions for that?
There is. We've already worked on, and we have on the test bench right now, an outdoor rated cell, but there will be limitations to that, and it will be environmental conditions. Let's use Arizona. You do not want a lithium cell on the south wall in an exterior manner that can get 120 degrees. That's just not a battery cell. Should be considered like the human body. It's going to work harder at higher and colder temperatures. So, but there will be requirements. We're seeing that start to pop up in California. It seems to lead the way there. And it might be detached buildings versus attached buildings is something I've been reading about. Humless actually has been working on the 9540, which excitingly enough, we've got for the Universal Series about 30 days ago. That's a new listing that we've been working hard to get for the past 8 months, actually. But I expect to see some exterior, and New York City is another one when you might see more of an exterior rated component required, but there'll be other things that's adding parts, that's adding warming blankets, that's adding heat temperatures, that's adding a disconnect to the BMS to cut off for cold temperatures. So it's involved.
Is it a reasonable requirement? I mean, do you see the risk of installing it in a garage?
No, we use lithium iron phosphate, which is not fire prone like lithium ion, I'm sorry. And it really just, even the thermal runway tests we've done don't start a fire. They just really create an ash. So it's not reasonable, but that's not the answer when we dig into UL listings and we talk to engineers. And there is a difference in chemical cells. And let's look at another example of that. How many Teslas are parked in garages in the United States right now? That's a different version of the same thing. So it's reasonable can't be discussed that way. What we have to do is look at requirements, look at needs, look at what has to be produced to keep everyone happy.
Yeah, but maybe somebody needs to put reasoning into the NEC code and change it back.
That will be one part of it. Yeah.
Another question to you, E, about the market. Do you anticipate module manufacturers to embed the RSD components into the solar panels? Do you see a movement like that?
Actually, we had been initially starting this program the same time as when we started RSD project. We had been tried many years. It's very hard. We failed a couple of times. One of the major reasons because the requirement for higher reliability in the field. You see, we can make the chip. It's not that hard. But how would you integrate it into your J-box and become a van, a part of your PV module portion? That's the risk. And the risk is very high. Most things, be honest, we failed by this point because it's also the logistic or management issue because we have to talk to the J-box manufacturer. We are not a J-box producer, right? So between us, J-box manufacturer, PV module manufacturer, there's too much points. You try to integrate it in one piece. So our experience basically is if you want to design that direction, you better do the design integrated as a van, not by piece. You're facing very high reliability concern.
Yeah.
And, another issue is in the field, in the system, you kind of lost your flexibilities because when you integrate your JBox, if the device failed, what you're gonna do is you have to replace the whole module.
True.
Rather than, right now just a piece of the part.
Yeah, but this brings up another issue that was brought up about MLPE, that once you're adding an MLPE to the system, you're adding more connection points, which are maybe more dangerous, or sometimes, or in most cases, are the cause for fires. And if there is a demand to add RSD now, you're adding more connections and you're actually increasing the risk of fire.
Yes and no. Yes, you're right, because you're adding more points by conductor or connector connections. That's true, and most failure based on the NREL discovered is higher risk of focusing on the conductor, especially the connector portion. What we learned is the most failure will come from your connector is not matched, which means you have this type of the connector, but you install with another connector together. So that's the higher risk of the reliability and the safety issue. That's why our product, we sold in the US market only the MC4 original, which we really have a long-term relationship and reliability study on it. And we believe that will be later on in the industry become standard in the US market. And as long as you have a matching with your connector perfectly, it should be fine. Well, at least we think it will be limited risk you will facing. Another point I just noticed that in the field is it's not true, because you think about our solution in here, the picture here, we have an input to the module side, right? We have output into the string. So we are facing the high voltage risk is on the output side only, which exactly same as normal system, right?
Makes sense.
Inside with the PV module, it's below 80 volts.
Mm-hmm.
We have been proved in the system that's not cause a really fire.
Okay.
50, yeah. And we learned if we losing over, you have like this mismatch or mismatch on a connector inside of module side, the only thing happen is they turn on the rapid shutdown function. They open the circuit immediately.
Yeah.
And there is no risk at all. You will see this module being bypassed in the string, but they already have no power at all.
You convinced me. One question about compatibility of connectors. This is a long time discussion. We see that question coming up with SolarEdge for years, with Enphase and Tigo and APsmart and AP Systems, and it is a question I don't understand it, because manufacturers are saying our connectors are MC4 compatible. So if they are MC4 compatible, what is the mismatch there? I mean, why is there a mismatch, or why manufacturers will go and waive the warranty if I'm using a connector that is claiming to be MC4 compatible? That's for you, E.
Be honest, I really don't know. What I learned in the field is it doesn't matter is compatible, original, or PS4, or any kind of a special designed connector. The best solution will be matching, because when they design, they suppose design with matching each other, female, male together to make a perfect contact.
Yeah.
Right? As long as it's not really matching each other, whatever is MC4 original or compatible, even just a tiny gap under high voltage will be the high risk.
Yeah. Yeah, but I mean, from a distributor standpoint, this is really hard to do because each manufacturer, every time we're ordering a new
Yeah.
container of panels,
Mhm.
we'll simply get a completely different connector. Everybody are saying that they are MC4 compatible, and you're bringing a valid point, saying maybe they do think that, but it's not necessarily the case, and the risk is high. So it is something that the market will need to address, I believe, and start using one connector or one design that is open source, right? I mean, we don't want a monopoly. We want open source type of movement, rather.
I think just to chime in on this topic, there was an interesting workshop at the latest NAPSEP conference in Knoxville, just talking about this. You know, it's been many years in which everybody has talked about the lack of compatibility, the amount of risks, the amount of like hazards that can happen when things don't match up. And the main takeaway from that was that there's no standardized global protocol for this, right? There's no UL certification, and everybody's pointing fingers that somebody else is going to take the lead. And nobody has really said, hey, we need to move forward on putting an all-encompassing UL certification on compatibility of connectors, because there's just way too many of them until things will continue to go wrong. So maybe that's how things can get solved, but it's definitely a topic that
Yeah.
you know, even in NAPSIP we're talking about that.
So the
Yeah,
solution that
correct.
the solution that the US came with is good for you, because they thought that the best way to solve it is by adding a rapid shutdown to the system. Okay, I'd like to move to another topic, which is customer needs now. Several questions about that, and I'll start with a question to Eric from Humless. When the energy storage market started, we saw projects that are installing 5 kilowatt hour, maybe 10 kilowatt hour range systems. And now we do see more and more customers that are looking for the 18 plus, maybe 40 kilowatt hour battery storage. How do you see that from your seat?
Again, this goes to perception has changed to the customer, and it's matching array size and family size and home size to what the customer needs. Our most popular options, hands down, are the 20 kilowatt hour, 30 kilowatt hour, and 40 kilowatt hour. We do a smaller option called the 10-4, which is a fantastic emergency backup system for smaller arrays and smaller families. But quickly people learned that reserve fuel source, that battery source, is a tank of gas. And if it's smaller, they may want to put more items on it immediately. And that's what people are, again, that's perception and people learning what they need. So we definitely are seeing it larger, and it's been fast also. Immediately, and also array sizes are larger. Some of these larger families and these larger homes have 7K, 8K, 10K arrays. So that limits and changes what they can get to match the storage to the exact array size. So I am definitely seeing it larger. We build in any block of 5. So the Humless 5 kilowatt hour cell can be built in any block of 5 up to 90 kilowatt hours. So I agree with you, actually. 20 seems to be the go-to number. 20s and 30 kilowatt hours are our most popular items.
Do you think that next year it will be 40 and 50, or 20 to 30 is really what a family needs?
It's the go-to because critical loads. You're again matching array size and family size, but when we start to add up critical loads, the larger families, they have 2 freezers and they have 2 refrigerators, and they may be more remote, and they do have a well pump. As soon as the well pumps and certain items come into the picture, it's a larger system. So once you add up the priority critical loads list, it leans towards the 20 kilowatt hour as a minimum. Now, again, there's plenty of families out there that just want a refrigerator, their security, their TV on, and some lighting, and they have a small 3K array. That does exist, but the bulk of our customers seem to be going 20 and above.
And maybe it's a budget. It's a matter of budget, because a 20K battery storage today costs the same as a 10 kilowatt cost a year or two ago, right?
It is 100% a consideration in the whole. The ROI of return and the cost is definitely a big part of the conversation.
Talking about sizing, Jim, I wanted to ask you about your inverters. Your line of residential ends at 6 kilowatt, and I wanted to know if there is a reason for that, or this is evolution, and then you're going to hit higher power capacities or outputs.
Sure. Yeah, and ABB had offered inverters with larger outputs in the past. And when FIMER purchased the Power One line from ABB, they had to make some, business decisions. They had to, concentrate their manufacturing efforts in certain spots and make a couple decisions. And one of those decisions was to temporarily stop production of anything larger than 6 kilowatts. Now, FIMER does plan to reintroduce those units in the future time, but for the moment, for at least the current product line, 6 kilowatts is the largest that we will be supplying. Now, it should be noted that, if you download the NEM data for the state of California, the average system size for SDG&E customers and Con Edison and PG&E, it's right around 7 kilowatts. Well, that's easily supported with a single FIMER inverter right now, our current product line. Would we like to have larger ones back? Of course. I'm asked about this almost every day, and it's on the drawing board, and it almost certainly will be happening fairly soon. But the good news is that for over half the installations right now that are being done here in California, there's a FIMER inverter that can do it with a single installation, do it at a very competitive price point as well.
Talking about the inverters and the development, when the rapid shutdown devices were introduced, we need to install also transmitters, and there are several ways to install transmitters in a system. One of them, which is offered, I think, also by FIMER and other manufacturers now, is something that is pre-installed at the factory, which adds more line items, because we have APsmart and we have Tigo and other rapid shutdown solutions, which requires different transmitters. Is it possible to let the installer install the specific transmitter that he likes to work with in your inverters, rather than having external box?
Sure, and Juan, why don't you take this one? You're a little bit more the expert than me on this.
I think so. I think I can talk a little bit about how the UNO DM inverters are right now, right? And FIMER has always focused on being as installer friendly as possible, and that's why we have our QR code commissioning process that takes less than 3 minutes to commission the system. But when we talk specifically about the rapid shutdown, the inverters right now do have a transmitter that can work with the ABB solution for string level rapid shutdown. That was back for NEC 2014, and that eliminated a number of parts. As code progressed and NEC 2017 came along, and all these different providers come with different advantages or solutions to meet the code, we're agnostic to those solutions. And our DIN rail continues to be large enough so that those transmitters can be quickly installed in there. We can do it at the factory for you, or we can also let the installer do it at the field. It's very simple. And we work really well with Yi to provide guidance as to how simple it is to click it on. It's fast to remove the wire box cover, put it on, and that's it. So we continue to be agnostic to the types of solutions there are, because the preferences of the homeowner are different. But we stand to simplify the process as much as possible. Integrated inside of the wire box is key for us.
Sounds good. Do you have anything to add to integration of rapid shutdown transmitters into inverters?
We are under some spec on line C. Basically, any transmitter manufacturer which belong to this line C supposed to talk to each other. I do know actually the Tigo transmitter is working with our receiver as well. So yeah, as long as it's the same technology, same requirement, They should working together. There might be different, slightly different, but yeah, should be talked.
So you were saying that if I'm purchasing an inverter that is came already with a Tigo transmitter, I can simply use use APsmart receivers.
Yeah.
Okay, and that's transmitter. What?
Yeah.
Okay. Okay, I would like to move to a different topic, maybe Humless. Eric, can you talk a little bit about the whole home backup? It's maybe going back to the former question to you. I see, or at least many customers are starting to talk with us rather than on critical loads, that they want a whole home backup. What changes are needed into the design and maybe the capacity of a system in order to address this movement?
It is a big movement. It's a very common question, but there's also a consumer lack of understanding about what a whole home backup would be. Let's use the different size service panels. Again, we're back to home size and family size. Is it a little 120 amp, 125 amp panel? Is it a 200 amp panel? Is it the rare Sun Valley, Park City 400 and 800 amp main service panel? So we really try to educate the customer as much as possible about, do you want to run priority loads and critical loads in an emergency, or do you want whole home backup? That's system sizing. The Universal Series is fully stackable. So that means we can stack multiple inverters with larger battery banks. So then you're getting up into the 90 and 100 amp range of whole home backup. This is doable, but then we're right back to expense. And I have to be fair, I found that I do have some very successful customers in the Sun Valleys of the world and the Park Cities and Virgin Islands and Caribbean, but most consumers start to look at their array size in priority and emergency loads because of the cost. So when we do whole home, though, there will be two requirements. We will need to change the priority loads panel to a large panel, or we put in a complete ATS automatic transfer switch and the system switches over at grid failure. However, and I think this is key, by doing an ATS like that, you really lose some of the daily driver aspects of a battery system like this, because it's waiting for the grid to fail and switch over to the battery system immediately. I prefer priority load panels because we can drive loads and power loads and use it more of a daily driver. So again, that's a complicated answer, and it really changes from customer to customer to customer and installer from installer to installer.
Have you seen any increase in discussion or talk or requests from customers and some like smart load controllers or panels where people can shed loads as they're needed while still providing sort of that access to power anything in the home if they wanted to?
Hundreds of them. So there's hundreds of systems out there with Lumen and Span, and I am actually working with another smart panel company that I'm pretty excited about because of that reason. So that is also the way the market is being driven due to this. People are looking more and more for the smart home features of an energy storage system with their PV array. And that is a good example, is just monitoring. Everybody wants to monitor their PV array and know what it's doing from their phone. Well, by using a smart panel, and then it comes to the cost again, let's talk about that. That priority loads panel, when we make that panel, we buy a panel, we buy all the extra wire, we have a master electrician to switch everything over to critical priority loads. That's a cost we can reflect on switching over to a smart panel. And by using a smart panel, now the whole house can be backed up and just drop loads in a low battery condition or fear of overpowering the inverter. We do some simple load shedding. So that is also an exciting thing that I think is changing fast as well.
Go ahead.
Oh yeah. So just to kind of then, I guess, jump forward a little bit and talk a little bit more about the technology. A question for Jim about, I guess, what your thoughts are on the current benefits of string inverters over an MLPE.
Sure. I get this question frequently, and it always makes me smile because most solar installers have forgotten how reluctant they were to try module power electronics. I know this from personal experience. I used to work for an MLPE manufacturer, and getting people to want to switch to microinverters or to optimizers was incredibly difficult. You've been doing it one way, and why would you want to change to something which is inherently more complex? There are inherent advantages to prefer string inverters over module level power electronics, and everybody knows them. You know, microinverters and optimizers, they add labor hours, they add complexity. They're expensive, obviously, they cost a lot more. Do you really want to give homeowners module level monitoring? All that does is encourage, you know, extra service calls when two adjacent modules have outputs that differ by 5 watts, and the homeowner wants to know why are they getting the difference. I mean, the list is as long as my arm about the problems that come along with this. But what I like to point out is just the high efficiency of today's inverters. Take an inverter that does, say, now 97% efficiency. And we all see that in a data sheet, and we don't think too much about it. But if you think about it, you know, the inverter installer should be asking, what happens to that 3%? And the answer, of course, to that 3% is that it's lost, it's discharged as heat. And everybody understands this. Everybody knows that heat is bad for electronics. Doesn't make any difference if it's your radio or an inverter or anything. Nobody wants heat in your electronics. You put your iPhone out on the patio in the summertime, and what happens? It powers down, says, move me to a shaded location. Why? Because it heated up, and that reduced the efficiency of the electronic device. Well, where's the hottest place on the house? The roof, obviously. So from pure common sense and logic, you want to find a way to remove as many as many heat sensitive power electronics from the roof. Take them off the roof and bring them into a secure, more temperature controlled location. And that's what string inverters do. The two most important functions of multi-level module level power electronics is MPPT and inversion. Those are two very heat sensitive processes. String inverters do this. They do it more efficiently. They do it in a much safer environment, and they do it at a much lower price.
Talking about module level monitoring, do you have any plans to add a little bit more capabilities to the APsmart components, like module level monitoring?
Actually, we do have that product already, but we are not selling in the US market. There are a couple of the concerns we have. The one is more because you add more function, right? So your size of your device will be increased, and there is a higher reliability issue or risk when you're doing that as well. So another thing is the cost. So adding the module level power monitoring system is not cheaper. So definitely you will increase the cost of your device. So for what we're learning from the US market is see the NEC 2017 and 2020 code is mainly for the safety and for the firefighters. But you turn around and look at another side is you can think about it as a burden for your customer, for EPC, for end users, is that right? So you're adding the cost. You have to add additional cost. So yesterday, actually, one of my customers called me, say, how much your price? And you know, my selling price is only that much. And if I adding your device, it's gonna go even 30 more or 40 more % of my cost overall to the customer. See, that's the feedback we learned from the US market. And we believe is the device we design should be not getting too much more than maybe our proposition for our product is to fulfill this gap with limited cost, adding into your customer, right? So that's why initially we designed this device with just as simple as possible. We only have an NEC rapid shutdown function. No, and in reality, we did know. Actually, later on, we can present later on with another webinar. As long as you are using the monitoring portal on the string inverter, you can perfectly monitor your rapid shutdown device. You don't need your module level monitoring system because as long as they fail, they bypass this module by certain voltage. It's about like 30 volt or 25 volt around. And then you can immediately see on your monitoring portal on the voltage level on your system. And at that point, you can immediately know your device has a problem in the field. You can add AI function into your program and immediately pick up the failing point. And we do have a like step-by-step troubleshooting procedure. It's very easy ongoing, and can find out where the location failed without just take out one by one module disassembly. So my point is you don't need a monitoring on a module level.
I mean, usually you are pairing your product, the APsmart, with string inverters, which if we're asking a customer if they want a string inverter to reduce costs, they would say, yes, string inverter maybe is cheaper and maybe a better solution in many cases, but I don't have module level monitoring, which obviously in the US at least, I mean, we spoke about the differences between the UK and Germany and other European markets and Australia and the US. In the US, module level monitoring became a standard, which is maybe missing in string inverters, and that could maybe solve it, because anyways, if I'm installing a string inverter now, I need to install MLPE for rapid shutdown, and I could solve that too, and might be a good offering as additional product, another line item.
I agree. Yeah. But we just keep evaluate if the cost or marketing they're really gathering. But yeah, we do have a product really for that.
Yeah, I was just going to mention, chime in, that's a new phenomenon in the U.S. and it's been interesting to talk to installers, because the first instinct is that homeowners do want that, right? But then you talk to the homeowner says, I really don't check it. It's knowing that they can have it, but they really don't check it. And then when they check it, then they call their installer to find out, hey, there's a 5-watt mismatch between them. And then the installer is like, well, now I regret offering this in the first place, because now I have to go and service it and inspect it, and then they're losing time for that, so time and money. So it's a little bit of a double-sided sword with module level monitoring, and I don't think it's necessary for a full system.
I want to ask Eric about monitoring for storage systems. Do you see that market evolves with the information that energy storage systems providing owners?
Yes, it's a request that commonly comes in. That's why it's a great question. Is we do provide monitoring, and if it's AC and DC coupled, it will show the AC couple array coming in as well as what the MPPT DC coupled array is also producing. But that is a very, very common request, is they want to see production from a distance. And again, this can be the consumer that wants to see what their array is producing and what their battery voltage is from work, or even more common is a question is while they're on vacation, or maybe their family is staying in their home, they want to monitor their system. So we do provide that. I was wondering, maybe I'll talk to E about this later, is E, we could run a test where we could run your AP into our DC array, and we'll be able to see the voltage and be able to see the production on our MPPT monitoring. So, but we are providing that, and it's a very common request. Customers, Juan's right. I call it new art on the wall. They get these new systems, they look at their monitoring constantly for the first 2 weeks or a month, and then they never look at it again. So or they look at it once a year. So it's interesting, but it is a request and it is consumer driven.
I see. Okay. Yeah, we can actually work on it.
Maybe the solution would be push alerts rather than asking the customer to look at it, right? Receiving an email in the morning, listen, you have a mismatch here, might justify that. But
Right.
Well, and I also believe we should be looking at the other thing. We shouldn't be getting specific into each panel, but looking at the whole house and the energy usage of the whole house and how that ties into EV chargers and storage. And I think that's a little bit of where we need to be going as an industry, is focusing on energy efficiency and how the energy consumption and production is measured at a whole home level, not at a panel level. So that's a little bit of what's coming down the road, as well as we update our monitoring platform, release our EV chargers and storage, so that homeowners can see that smart home flexibility through the FIMER app, right? And how it can be just very simple to read without just becoming obsessed over a couple watts here and there.
Correct. Changing the costs. We don't want to affect the cost and make the cost go up. The consumer doesn't want that. And if all they really want to see is power in and power produced and power out, and that's all we need to do, that helps the consumer.
Mm-hmm.
I'd like to share quickly, give me a couple of minutes, my experience back to years ago when I was working in Canada market for the microinverter department. So most customer did not check their performance on daily basis unless something involved with their money. For certain area, I remember some of the customer on daily basis to check their performance, because the policy on the government requirement is your energy produced by the solar cannot over a certain range. Otherwise, you get to be penalty or you lost a certain money. So those area, the customer on daily basis, they check in their performance very carefully, every day chasing me. So that's the reason they have a driving. You need to put a driving, into their mind. Then they will check every day.
interesting.
Money drive, basically.
Yeah, money drives us all. I wanted to ask about three-phase commercial energy storage systems, and that involves also inverters and batteries, different sizes, different maybe setups. How do you see that market evolving now? This is a question both to FIMER and to Humless.
So it's evolving interestingly, globally and nationally, right? We see a little emergence of players that focus on MLPE solutions for the commercial storage, but also FIMER, in the beginning of the month, they announced a new power platform. And so with the power platform came the Power Trio. And the Power Trio is a three-phase commercial inverter that is a hybrid commercial inverter. This will coincide with the Power X modules, and right now they don't have any plans to bring it in the United States in the near future. As things pan out in the commercial segment, and then we start understanding how each market in the United States is going to perform for commercial hybrid storage. But the company is trending because that's where the global trend is headed, right? Is commercial storage, and that's a little bit of the Power Trio and the Power X that are available in other parts of the world next year.
Eric, how do you see the three-phase commercial market changing or evolving?
I see it evolving quickly in the same manner and I've had a lot of that interest in the last year. Load shaving. A lot of these larger companies are really getting hit with load shaving. I can use a California customer where the utility actually figured out that because they were more of a nighttime driven business, they were going to change their time of use, which kind of blew my mind. I wondered about the legality of that. But the point is if they can have a bill that turns out to be 60 to 70%, a high tier, and then they could load shave that portion of the bill, they can dramatically change that utility cost. Then it immediately switches over by using energy storage to push that power and do that load shaving. That energy storage is there to run priority loads when the grid fails. And that's an example of smaller commercial. I'm going to use the Virgin Islands again, where I have customers that if they lose their refrigeration and freezers, they lose a huge amount of inventory. So one, in the Caribbean, they can load shave their higher costs for their air conditioning needs and their refrigeration needs. But when the grid does shut down more commonly there, they have the ability to protect their inventory. So the cost savings are quite dramatic when you look in, especially the small commercial to the larger scale market. Then we get above that, like huge meat producers, and their costs are so high that then they start to look at the return. It really depends on where they are, what their utility costs are per kilowatt hour, but it's been a big portion of what we do over here, and that is larger containerized solutions. We're very proud of our 40 kilowatt block inverter that can work with any three-phase, meaning on one group down the road, we're at 480 V, but if we move down to a different location, that customer can get the same system in B277, so 208. We have a lot of options that way. So I think it's another growth market that we're going to see more of.
And talking about it, I see more low voltage batteries now coming into the market, while the market started with high voltage batteries. What is your thoughts about, what are your thoughts about high voltage batteries? That's Eric's question.
Internationally, the voltage platform internationally is a 48 volt. If you go into the Africa, Asia, part of the European world, everything's based on a 48 volt platform because it's the most common. Tesla and other groups started with a higher voltage battery, and there is advantages. In larger systems, we are the same. In the commercialized and containerized solution I just spoke to, that's a 700 volt nominal battery bank, and that's to affect costs, to lower wiring costs, to lower the fuse costs. There's a lot of factors involved there. I happen to think that the 48 volt platform is still the key in the small residential market due to how it works and how we can set it up to match inverters and how the battery banks are lower voltage for safety. UL likes that. But as you get larger, we kind of recommend anything over 100 to 120 kilowatt hours, we're going to be at a higher voltage. And that's just what we recommend. So I see the two. For some reason, what we see in the market is 48 volt, smaller systems, residential, and then we're a little higher voltage than some of the Teslas of the world. They're kind of a funny voltage, but we're seeing a 600 to 700 volt nominal battery bank in the larger commercial 480 volt.
Nice. One last question, I think, about lesson learned and the capability of installers to deal with energy storage, rapid shutdown, strings. What do you see in the market? This is a question for everybody. What do you see knowledge-wise happening in the market, in the installers side? And what would you like to see or change?
The American market and the battery market is very, very new. In Africa and Asia and Europe, they've been doing this for decades. But the American market is still so focused on current source devices, a simple grid-tied push device, that I would like to see more installers. I'm not being disparaging here, but I would like to see more installers study up and learn battery bank systems and the requirements needed. It is different. Laying glass on a roof and pushing it through a current source device to a fuse to a net meter is one form of solar in America now, but the other part is adding storage, adding critical loads, adding ATSs. And I would like to see, and we are actually working on a training program. We're going to make it mandatory for any of our larger systems. We're pretty proud of the simple, easy, one stacked, very simple 20 kilowatt hour system. It's AC in, MPPT in, AC out to priority loads. That's pretty simple. But I still think the American contracting and PV solar market's got a ways to go. It's important that training continues to evolve. It's important that people continue to learn more.
Jim, do you want to add something and I'll follow up?
Sure. I think that the ongoing education of energy storage is never going to end. Most homeowners think that electricity is magic, right? I know I plug it in and it works. And the questions about battery chemistry often make me smile, because the number of times an installer has told me that their homeowners ask for a specific battery chemistry, I can count on one hand. What most homeowners want is to know that the television will stay on so they can watch the ball game, and there'll be a cold beer in the fridge for them while they're doing it. And they want to make sure those loads are protected, and what the chemistry is that actually drives those that storage really isn't important to them. They want something that's reliable and low cost, and make sure that their loads are protected. And how you get there really is often the less important question.
Yeah, and I think that it's tough, because one thing is the lessons for installers, but the other thing is the lessons for salesmen as well, right? I think a lot of solar installation companies have become really good selling machines, right? And sometimes you can promise a homeowner unlimited energy with their solar system. Other times, you have to be careful about what is being sold. But from the installer point of view, it's important to also remember what will the system be like in 5, 10, or 25 years, right? And then we focus on what will the industry be like in 10 years. And so we want to keep things very simple so they can just install it, right? Know that it's reliable enough that it's going to work, and that it's going to be a much easier system to maintain over the lifetime. Right, which is a little bit of the benefit of string inverters and having simplicity on the roof, and counting on companies such as us that we've had inverter technology for 20 plus years, have continued to improve it, so that eventually, it can be a simple upgrade to the customer whenever it's needed. So I encourage to stick to the simple installation and affordability and reliability.
And if I could, one more quick comment here along the lines of what Juan is talking about. The best way to prevent mistakes for installers, and the list of best practices can go on forever and ever here, but I would say that there's 2 things that you can do, especially before your first installation, that are really going to make it easy. And number one, and this just sounds so basic and so simple, but it's true, just briefly glimpse at the quick installation guide before you start your project. It'll take 5 minutes, maybe 10 minutes. It'll probably save you 20 to 30 minutes out in the field. And the next is that you'll want to download the app. If you haven't already done so, download the app on your phone rather than do it on the customer site before you do your first job. Have the app downloaded, have your account set up so you can launch your system immediately, and the homeowner is going to have monitoring within 15 or 20 minutes of the time you walk out the door. If you just do those 2 things, especially before you do your first project, you'll be in and off the job site very quickly, very safely. The commissioning for our inverters is only about 3 minutes. We have a video that walks you through it and shows it to you in real time, how long it takes to install our inverters. Those 2 steps right there will probably save you 40 minutes on the job site. You'll have a much happier customer.
Yeah, we also experience when an installer is asking for the manufacturers to walk them through the installation process. I think all manufacturers are happy to set up a Zoom meeting or a phone call to go over the installation prior to the first installation of any product. So take advantage of that. Yeah.
Absolutely. Reach out. There's 3 regional sales managers for FIMER across the United States. Juan, myself, and our colleague Holly Bergeson, who's in Indiana. Whichever part of the country you're in, if you reach out to us, we will arrange for a member of our tech support team to help you out on that first project. And we can do this because it is really simple. It is really fast. We're not kidding when we say it takes 3 minutes to commission one of our inverters. We want you to get in and off that job site quickly. Call us, let us know you're going to do it. We'll walk you through it.
Okay.
Great.
Right.
Someone else have?
Yeah. So Jim have a good point. Actually, I've been working pretty hard on the training installer. That I know that it's a pretty hard job because normally an installer will learn from the job, most likely. That's the case. Anyway, yeah, but we do our best, and we have a toll-free number. Customer can directly call us on the site, and we even use the video outside to hand by hand to training a customer how to install that as well. So do our best to improve our service as another point. And another thing, I have for the module level power electronics, actually, I have some comments here. I have a little bit nervous, or not nervous, worried. Like Jim said, because you have a lot of equipment, model level power electronics on your roof, which is a hot place, and you generate heat, right? So there is a higher chance you get to be failed, cause the fire. That's the most case we learned. From another side, I learned since the pandemic started, I noticed that there are more fire in the field happen. And that significantly damaged the whole industry reputation. And most of them, what I will focus on is on the roof. They have like conductors or all kind of issues, including the power module level power electronics device. That put me trigger because I was working in the manufacturer, electronic manufacturer for years before. I know stabilize your manufacturing process is very, very important to deliver the qualified products, right? But since we get into the pandemic, guys keep moving the manufacturer around in the world, and all those chaos happen in different regions, and I don't know. I just get a sense that potentially they have a risk for all the products in the market. And for that point, when you design a product based on my reliability background, you need to learn the worst case scenario on the roof. That's why I really prefer on our product is we do have a failure. We have a very bad failure, and we have a worst case already happened. But that's already been proved. We never will cause the fire on the roof. That's due to our design. And that's already been recognized by even the firefighter or fire department, since they saw all kind of the fire on the roof by solar product. So yeah, just my comments here. Exactly all of the standard, NEC standard, and UL standard, and carefully design your device to as simple as possible. That's one of the key to really nail down the fire issue. Otherwise, they put the industry in a very hard place.
And if I could add one comment to what Yi just mentioned, this is really, really important, especially for all the installers that are on this call here. Homeowners will often be quick to point out a story that they recently heard about, quote unquote, a recent fire, right? Did you hear about this fire? Did you hear about that fire? When you get that question from a homeowner, you'll want to point out to them that the reason that they heard about this fire is because it is so unusual. Yes, they do occasionally happen, but for the most part, the PV business is incredibly well managed. It's incredibly well regulated, and the vast majority of installations don't have problems. Literally, the numbers that do with problems like fires is literally thousands of a percentage point. It almost doesn't happen. And the only reason that they heard about this fire is because it is so unusual. I'll also go a step further to APsmart's credit, something I mentioned a little while ago. Their quick installation guide is only 3 steps. You know, just taking the time to look at that before you start this start the work, it literally takes 30 seconds to snap, at most, to snap an APsmart module or APsmart switch rather on the back of a module. And just knowing that what you're going to be doing before you get to the job site is going to make the experience much better and much faster for everybody involved. And again, yes, module level power electronics are inherently more fire prone than string inverters. If you have a client that is concerned about electronics on the roof, this is one of the first things you want to tell them, is that if you use a string inverter, such as one from FIMER with an APsmart rapid shutdown device, they're probably going to have a much lower chance of that.
Mm-hmm. And you mentioned quick start guide, and I think Humless is an amazing quick start guide too, right? Their 10.4 is like a single 1 page. It has like 10 steps, all the tools. You know, it's really well done. I think that's what all 3 of us are focusing on. You know, it's like, how do we make it as simple as possible? So
we shouldn't even have to say read the manual.
yeah,
Shouldn't have to say.
let's read the quick start guide.
Right.
Excellent. That was a great, I think, sort of wrap up or end of the conversation. So we'll go ahead and close things out there. I want to thank everybody again for joining. I think it was a great conversation, a lot of good information. If anybody who was listening in or watching has any questions, feel free to reach out to us, and we're happy to answer them if we didn't get to them during the conversation. So yeah, cool. So yeah, thanks again, everybody.
Thanks, everybody.
Thank you.
Thank you very much.
Thank you, RENVU. Appreciate you guys having us on.
I appreciate it, guys. Nice day.
All right.